Somewhere in the 1990s, a neuroscientist was recording electrical signals from neurons deep inside a monkey's brain, and he stumbled onto something that would eventually reframe how researchers think about human behavior entirely. What he found goes straight to something most people never fully understand about themselves. Why discipline feels like constant effort for most people, while others seem to do the same things almost effortlessly, and even enjoy them. The common explanation is willpower, that some people simply have more of it. But neuroscience points somewhere else entirely, to a mechanism that has nothing to do with how determined you are and everything to do with what your brain has learned to anticipate. And that mechanism can be deliberately trained. The neuroscientist was Wolfram Schultz, and what he was doing was deceptively simple, placing electrodes near dopamine neurons in the midbrain of macaque monkeys and waiting to see what fired. The setup had a straightforward logic. A light would flash, and a few seconds later, the monkey would receive a drop of juice. Schultz expected the dopamine neurons to respond when the reward arrived. In the early trials, they did, firing reliably at the moment the juice appeared. But as the experiment repeated, and the monkey learned that the light predicted the juice, the pattern changed in a way nobody had anticipated. The neurons stopped responding to the reward. They started responding to the light, the signal that came before it. The brain had quietly shifted its attention away from the outcome and toward the moment it recognized something familiar was coming. Schultz published these findings in Science in 1997. What followed was years of research trying to understand what this meant outside a laboratory. What it eventually mapped onto was the way humans relate to effort over time, and why that relationship looks so different from person to person. When someone starts a new discipline, the brain has no pattern to work with yet. The effort is just friction, discomfort with nothing attached to it. But with enough repetition in a consistent context, something shifts. The behavior becomes a cue the brain recognizes, and the dopamine response migrates earlier toward the moment the habit begins, sometimes toward the mere anticipation of it. Experienced runners describe this in ways that sound almost foreign to someone who has never run consistently. Not just tolerance for the effort, but an actual pull toward it, a feeling that something is missing on days they can't go. What most people don't realize is that this shift can be influenced deliberately, that there are specific conditions under which the brain builds that association faster, and specific things that prevent it from building at all. One of the clearest findings to come out of the research that followed Schultz's work involves something called context consistency. Anne Graybiel at MIT spent years studying how the basal ganglia, a region deep in the brain involved in habit formation, encodes repeated behaviors. What her lab found was that the brain responds to repetition in a stable context. Same time, same place, same sequence of events surrounding the behavior. When those elements are consistent, the brain chunks the entire pattern into a single automated unit far more efficiently than when the conditions keep changing. When you work out at the same gym, at the same time, after the same trigger, the brain isn't just learning the workout, it's learning the whole sequence. Over time, those elements start functioning as a runway. The decision to go gets made earlier and earlier until it barely feels like a decision at all. When the context keeps shifting, sometimes morning, sometimes evening, sometimes at home, sometimes at the gym, the brain never gets to build that runway. Every session feels like the first one because neurologically, it kind of is. The second condition is immediate feedback. And this is where most people run into trouble without realizing it. The dopamine system is exquisitely sensitive to timing. Rewards that arrive long after a behavior, like better health in 6 months, a promotion next year, the body you want by summer, don't teach the brain to anticipate the process. By the time the result shows up, the brain has no clear memory of which specific behavior produced it, so no strong association gets built. What accelerates the shift is something that closes the loop immediately. Anything the brain can register as a signal that the behavior just produced something right now. The people who seem to have discipline figured out tend to have found something in the process itself that delivers that immediate signal. The discipline looks effortless from the outside because the brain stopped treating it as effort a long time ago. It's chasing something it already knows is coming. There's a third condition that the research points to, and it's the one that tends to separate people who build lasting discipline from people who cycle through the same habits repeatedly without them ever sticking. In the mid-2000s, a psychologist named Wendy Wood at Duke University ran a series of studies trying to understand why some people maintained new behaviors long-term, while others abandoned them within weeks. even when motivation levels were similar at the start. What she found was that the people who stuck with behaviors longest weren't necessarily more motivated or more consistent. They had integrated the behavior into how they thought about themselves, not "I'm trying to work out more," something closer to "I am someone who trains." The difference may sound small, but the effect on behavior isn't. When a behavior becomes part of how someone defines themselves, the brain starts protecting it differently. Missing a session stops feeling like a missed opportunity and starts feeling like a small violation of something, an inconsistency between who you are and what you did. That tension is uncomfortable enough that the brain starts working to avoid it, which means showing up becomes the path of least resistance rather than the harder choice. This maps onto something neuroscientist Elliot Berkman at the University of Oregon has studied extensively: the overlap between identity and value in the brain. His research shows that goals connected to self-concept activate reward circuitry more reliably and more durably than goals framed purely around outcomes. The brain doesn't just want the result. It wants to be the kind of person who gets that result, and that want is neurologically distinct from ordinary motivation. The practical implication is uncomfortable for anyone who prefers to think of discipline as purely a matter of effort, because it suggests that the question isn't just "how do I make myself do this?" It's "who am I when I do this, and does that person feel real to me yet?" By now you understand what separates someone who builds lasting discipline from someone who doesn't: a stable context, an immediate feedback loop, and an identity the brain has started to protect. But knowing that isn't enough to get you through the hardest part. Because the hardest part isn't building the right conditions, it's surviving the weeks before those conditions produce anything you can feel. There's a specific point in the early weeks of any new discipline where most people quit. And it's not random. Wendy Wood at USC spent years analyzing habit formation data and found that the dropout rate for new behaviors follows a consistent pattern. The first 2 weeks are often manageable, carried by novelty and initial motivation. It's somewhere between week 3 and week 6 that the novelty wears off, the motivation fades, and the brain hasn't yet built enough of an association to pull the person forward on its own. The effort feels exactly as hard as it did on day 1, and there's no internal signal yet to justify continuing. This is the window where most people make a decision that feels rational, but is actually a misreading of what's happening. They interpret the difficulty as evidence. Evidence that they're not the kind of person who can do this, that the habit doesn't suit them, that they started at the wrong time or with the wrong approach. What they don't know is that they stopped about 2 weeks before the brain would have started changing. Research on habit automaticity has produced a number that's more variable than the popular 21 days claim suggests. A 2010 study by Philippa Lally at University College London tracked 96 people forming new habits over 12 weeks and found that automaticity developed anywhere between 18 and 254 days, with a median around 66 days. The range is wide because it depends heavily on the complexity of the behavior and how consistently the conditions are met. But the pattern was consistent across participants. The feeling of effort doesn't decrease linearly. It plateaus for a while, sometimes for weeks, and then drops more sharply once the brain has accumulated enough repetitions to start chunking the behavior. The people who make it through that plateau aren't necessarily more disciplined, they're often just better at misreading their own discomfort, interpreting the flatness of that period as normal rather than as a signal to stop. This is where the conditions matter most. Context, consistency, and immediate feedback don't just accelerate the shift, they make the plateau survivable. When the behavior is anchored to a stable context, showing up requires less conscious decision-making, which means less opportunity for the brain to talk itself out of it. When there's an immediate signal closing the loop, each session produces something the brain can register even when the long-term results aren't visible yet. The accumulated repetitions keep building underneath the surface, even when nothing feels like it's changing. Missing a session during the early weeks doesn't reset the association. The neural pathways that have started forming don't disappear overnight. But the way most people respond to missing a session does significant damage, not to the habit itself, but to the identity that was starting to form around it. One missed day becomes evidence for the old narrative. I knew I couldn't stick with this. I always do this. And that story is often far more durable than the habit ever got the chance to be. What the research on identity-based behavior change suggests is that the response to a missed session matters more than the missed session itself. The brain is still building a self-image from the available evidence. A missed session followed by an immediate return sends a different signal than a missed session followed by 3 weeks of absence. The shift that Schultz's research points toward doesn't arrive on a schedule. It arrives when the brain has accumulated enough consistent repetitions in a stable enough context to trust that the pattern is real. And the only variable that determines whether that happens is whether the person is still showing up when it does. Most people never find out because they stopped somewhere in the middle. During the plateau, when the effort still felt expensive and the results hadn't appeared yet. They walked away from a process that was working because working and feeling like it's working are two very different things, and nobody told them that the gap between the two is temporary. The person down the street who seems to have discipline figured out went through the same plateau. The difference is that they kept showing up long enough for the brain to do what the brain does, and at some point, without any single moment marking the transition, it stopped feeling like discipline at all.